What's up, everyone? This is LeetCode 199 binary tree right side view. We've done this problem in Python. Now we're going to do it in C++. So we're given the root of a binary tree, and we have to imagine ourselves standing on the right side of it and return the values of the nodes you can see ordered from top to bottom. So in case you're confused by this problem statement, basically they're just telling you in this tree, go level by level and take the rightmost node and append that to an array, and then at the end return that array, right? So for example, when we go level by level here, the rightmost node is going to be 1, 3, 4, right? And that's what our output should be. Example 2, right? We have 1, 3, 4, 5, and that's what our output should be, right? Here, the root node is a 1, but then the left is null, the right is 3, so obviously we'd return 1, 3, which is what our output should be. And of course, we can have a root node which is empty. So that is an edge case we have to handle. So be mindful of that, right? Because the number of nodes in the tree can range from 0 to 100. So you can have 0 nodes in the tree, right? You can basically just have an empty tree. In that case, you have to obviously just return an empty array, right? So we're gonna start off by creating first our vector, which is just gonna be our answer vector, right? Of type int. We're gonna return this down here. Okay. Now, first of all, let's handle the edge case, okay? So we're gonna say if there's no root, right? We have an empty, basically, an empty tree, then just return answer, right? Which would be what? It would just be empty, right? Okay. So, like I said, we're gonna go level by level, right? And we're gonna take the rightmost node. The way we're gonna do this is we're gonna use a queue, right? A double-ended queue, and we're gonna process all the nodes in a particular level, right? Basically just a BFS approach. I'm sure there are various approaches to this problem, but I'm just going to do this approach because I think it's the most simple to understand. And I really don't see why you need... I don't really see the need to overcomplicate things by using some other strange approach. So we're just going to do a BFS, right? Using a queue, right? And we're just going to process the nodes that way for every level, right? So let's create our queue here, right? Type tree node. We're going to call it queue. We're going to initialize it by passing it the root, okay? Now, the root will always have something because obviously we handled the edge case up here. So we're not going to have an empty root, thankfully, right? So we're going to say while the queue is not empty, let's handle it, right? So if the queue is not empty, we need to basically define what nodes we want to process, right? Because we're going level by level, so we're adding these child nodes to the queue as well, right? So before we do anything, we need to basically define how many nodes are we going to process, right? Because let's say we're processing this 2 and this 3, our queue is going to have 2 nodes in it. But as we process this, we might add the 5, then the 4. Now our queue has 4 nodes, right? So, but we don't want to process all 4 nodes. We want to process only the first 2 because that's the level that we're on. So we're going to basically define our range for the level that we're on. Like, what nodes do we want to process right now? Right, on this particular level, because again, our queue could expand as we add child nodes, right? So we need to do that by basically defining the level length, okay? So we're going to say int level length, we're going to do queue.size, okay? And that's basically, the reason that's useful is because that defines our range for our for loop, okay? So we're going to say int I is 0, if I is less than the level length, right? We're going to do I plus, okay? And we're going to basically pop from the left side, right? So queue.front. Okay. We're going to pop. And basically the way we're going to do this is we're going to first of all, if there are child nodes for this particular node that we popped, let's add those. Okay? So if node.left has a child node, is a child node that exists, right? It's not empty, then we're going to put that to the queue, push that to the queue. So we're going to say queue.push. We're going to say node to the left, right? Right. Same with the right. So if node to the right exists, actually, I don't even need these. A little bit, keep our code a little bit cleaner. Okay. Since it's just one line, we're going to say node to the right. Okay. Now here is, where basically if I is at level length, that means we're at the rightmost node, right? That makes sense to you? Because we're defining our length, right, for this particular level, 2 and 3. So when the I is at 2 minus 1, so at index 1, it means that's our, so we're at index 0, index 1. Even though we added these to the queue, when we're at this index, this 3, right, because our queue would look like 2, 3, 5, 4, right? Well, when we're at level length minus 1, which would be 2 minus 1, right, because there's 2 nodes, minus 1, so 1. So when the I is equals to 1 here, it means this is the rightmost node for this level. So we want to add this particular node to our answer vector, okay? So this right here is basically the rightmost node at this level, right? That's basically all that is. So we're going to say answer.pushback node.value. And we need to actually add the node value, not the actual node, right? Because we're at return values. Okay. And then we do all that. And I believe that should be okay, unless I have some little syntax error or something. Yes, I do. Got my semicolon. Whoops. Down here. Let me submit really quick. See if we have any issues. It should be fine. And we're good. Okay. So basically, just to recap, what we're really doing is we're just going level by level using a queue, right? Just basic BFS stuff. I mean, this is a medium problem. I'm sure we've done a few tree problems already. Certainly, if you've been following my videos, we've done a few problems where we've used BFS on trees. So we have a queue, right? And we're just defining the level, right? Basically the range in our for loop, right? How many nodes should we process? Because we have we want to process 2 nodes, right? Well, maybe our queue could expand to 5, 6, 7 nodes, but we only care about whatever level that we're on, right? So if there's 1, 2, or no, I think like you wouldn't have like 7 nodes if you're branching off from 2, or maybe you would actually, depending on what level you're on. But the point is, like, you need to define how many nodes you want to process first, right? Which is what this is doing, this line here, because the queue could expand and you don't want to process those nodes as well because they're from the level below, right? We're only, otherwise how would we find the rightmost node for a particular level, right? So that's why this is important. And that's basically what we're doing. I mean, we're just going level by level and processing all the nodes in a particular level, right? And then moving forward and processing the nodes from the other level. I mean, it's really not too complicated. I mean, it really is that simple. I mean, I don't think I need to explain anything else. I mean, I think this code is pretty simple. I mean, for a medium problem, it is pretty simple. I hope it makes sense to you, but you can ask questions if it doesn't. And yeah, I hope this helped, and I'll see you in the next video. Peace out.